In last lecture, we have discussed different types of stress. In this lecture, I am going to discuss different types of strain. Okay, now let us see the different types of strain. Here, when we apply force normally on surface or area, then we are going to observe two types of strain. The first one is tensile or longitudinal strain, and the second one is compressive strain. Okay, let us see the first type, that is tensile or longitudinal strain. It is simply the fractional increase in length of an object due to tensile or longitudinal stress. Okay, to explain tensile or longitudinal stress, we need to take a rubber band. Its one end is fixed, then we are going to apply some amount of force on other end, then it's going to change its length. Here we can see that there is increase in length after applying force F. Okay, let us see diagrammatically. Here we are going to take one object. Its one end is fixed and it is having initial length L and cross sectional area A, and we are going to apply some amount of force F in downward direction. Then this object undergoes deformation, that is, there is increase in length. Here you can see that it is the initial length and this is the change in length after applying force F. When in this case the change in length per unit original length is defined as a longitudinal strain. What is longitudinal strain? It is simply change in length to the original length. Here you can see that we have taken an object, we have applied some amount of force F. After applying this force F, this body undergoes deformation, that is, there is increase in length. In this case, the change in length to the original length gives us longitudinal strain. Okay, now let us see second type, that is compressive strain. Here also same. In this case, we need to take example as a spring. Here what I am going to do, I am going to take a spring and its one end is fixed. Then I am going to apply force in upward direction. Then after applying force, this body undergoes deformation. And here we can see that there is change in length, that is, there is a decrease in length. Okay, let us see same situation diagrammatically. Here I have taken one object, its one end is fixed and it is having some initial length L and cross sectional area A. Then what we are going to do, we are going to apply force in upward direction. Then after applying this force, this body undergoes deformation, that is, there is decrease in, here you can see that there is a decrease in length, that is, delta L is the change in length. What we have done, this is the amount of force applied. Here you can see that we have taken one object and it is having initial length L, then we have applied force in upward direction. Then after applying this normal force, this body undergoes deformation, and here we can see that there is decrease in its length. In this case, we define compressive stress is the change in length to the original length. This ratio gives us compressive strain. Okay, here we have studied two types of strain. The first one is longitudinal strain and second one is compressive strain. In longitudinal strain, there is increase in length. At that time, the change in length to the original length gives us longitudinal strain. And in second case, that is in compressive stress, there is decrease in length. Then in this case, the change in length to the original length gives us compressive strain. Okay, now let us see next type of strain, that is volume strain. Volume strain is the change in the volume per unit original length of the body is known as a volume strain. To explain volume strain, we need to take one object and it is having some initial volume V1. Then I am going to apply force in all direction. Then after applying force, this body undergoes deformation, and after deformation its volume becomes V2. Then the change in volume is equals to V1 minus V2. Okay, let us see the same situation diagrammatically. Here I am going to take one object, then I am going to apply force F in all directions. Then after applying force F, this body undergoes deformation and it is having some original length or initial length L. Then after applying deforming force, this body undergoes deformation and it is having volume V2. Its initial volume is V1. Here after applying deforming force, this body undergoes deformation and its volume becomes V2, and this area gives us change in volume, that is delta V, which is equals to delta V is equals to V1 minus V2. Okay, now in this case we define volume strain as a delta V volume strain is equals to delta V, that is change in volume to the original length, that is L. Volume strain is simply, it is the ratio of change in volume to the original length. It is about volume strain. Okay, here what we have done, simple, we have taken one object, then we have applied force in all direction, that is after applying this deforming force, this body undergoes deformation and it is having volume V2 and it is the initial volume V1, and this distance gives us change in volume, and the volume strain is defined as the ratio of change in volume to the original length. Okay, now let us see the next type of strain, that is shear strain. Shear strain is the ratio of relative displacement to its perpendicular distance from fixed surface is known as a shear strain. To explain shear strain, we need to take one object, it is having some length L. Then what I am going to do, I am going to apply tangential force on this object. Then after applying tangential force, this body undergoes deformation, that is here you can see that there is some displacement. Here in this case we have fixed the lower end fixed, and we are going to apply tangential force on a upper surface. Here I will show once again. Here we have taken one object, its lower end is fixed. I am going to apply tangential force on a upper face. Then after applying tangential force, this body undergoes deformation. That is, here you can see that there is some displacement of this object. Here also you can see that there is some displacement of this object. Okay, let us see what is shear strain diagrammatically by taking same example. Here I am going to take one object, then I am going to apply some amount of force F, and it is having initial length L. Then after applying force, here you can see that, let us suppose this is original object. Then after applying force F, this is original length, it is force applied, tangential force applied. Then after applying this force, this body undergoes deformation. That is, there is some displacement, that is delta x, and this is the shear angle. Here also it is the shear angle. Let us suppose, if we denote this point as A, this is B, this is C, this point as a D. Here you can see that the point AB, that is lower surface AB, is fixed. I am going to apply tangential force on a surface CD or DC. Then after applying this force, this body undergoes deformation. Let us suppose this is the point A, B, this is C point, and this is D point. After applying tangential force, this body undergoes deformation. Then this point becomes D dash, and this is the C dash. That is, after deformation, this body after deformation, it becomes A, B, C dash, D dash. After deformation, this body takes new shape, that is A, B, C dash, D dash. Initially it is in A, B, C, D shape. After applying force, it takes new position, that is A, B, C dash, D dash. And here it makes an angle theta. This is the shear angle, this is the displacement. In this case, we define shear strain as a relative displacement per unit original length or perpendicular distance. Shear strain is simple. It is the relative displacement or angular displacement per unit perpendicular distance or original length. It is simple. Here you can see that shear strain is relative displacement per unit perpendicular length or original length. Okay, now we have studied three types of strain. In first case, we have applied normal force on an object. Then we have observed two types of strain. The first one is longitudinal strain, and longitudinal strain is equals to change in length to the original length. In this case, we observe that there is increase in length. In second case, compressive strain. Here we observe that there is decrease in length. In this case, compressive strain is defined as the change in length to the original length. And the second type is volume strain, and we have defined what is volume strain. Volume strain is simply change in volume to the original length. And the final third one is shear strain. Shear strain is the ratio of relative displacement to the perpendicular distance.